For day 2 of this unit, we're going to talk about surface area of prisms. We're going to go shape by shape here. Remember how I talked to you yesterday? Prisms are shapes that have 2 bases. Those bases can be any kind of polygon, regular polygon, irregular polygons, all that good stuff. We've got a bunch of vocab I'm going to throw at you once again. It's all in this little chunk of this paragraph, so bear with me here. The first thing we're going to talk about are the lateral faces. So if I take a look at some of my little props over here, and I take a look at these shapes. So for example, this guy. Whether it's standing upright or on its side, these 2 hexagons, these are going to be my bases, right? Your bases are always like the odd shape out, unless it's a rectangular prism like this, where you'll have rectangles as your bases and as your sides. Otherwise, your 2 bases are usually triangles, polygons, any kind of stuff like that, where all of the other faces of this shape will be rectangles. If you are looking at a shape and you pick 2 bases and then you look at the other sides and you have non-rectangular faces, that means you picked the wrong bases. The bases have to be the weird shapes if you have them. So in this case, those rectangular sides here, those faces, we call them lateral faces. We're going to see this word used a lot, this lateral. Lateral just means on the side. So all of those sides that are not the bases are lateral faces. We also have something called lateral edges. Those are all of the seams that join 2 of those rectangles together. So in this little diagram, we can kind of see all of those lateral edges on the sides. Okay, those are all of my lateral edges. And then similarly, I have the bases, okay, those 2 bases, and connecting the bases to the sides, we have base edges. So base edges touch the base. So all of these guys are base edges. Questions on those vocab words? Next is an altitude. An altitude goes from one base to the other. So it will be one of the lateral edges, usually in a right prism. So this from base to base, in this case, is called the altitude of this shape. And if we take the measure of that altitude, we find the height. Now, altitudes and height, they are always going to be perpendicular to the base, no matter what. So when I take a look at, this is a right prism where it's standing upright. When I lean that shape over, it's called an oblique prism. Now, the altitude and aka the height is now different because altitude and height are always going to be perpendicular to a base. And if those sides are slanted, obviously they're not perpendicular. So our altitude becomes a line outside of my shape because height is always perpendicular. Okay. So now I get to show you a little demonstration that I like to do. This is just kind of silly, but I think it helps with the visualization of this. We are going to see 2 different kinds of shapes. These right prisms and oblique prisms. One standing upright, one leaning on its side. The reason that we can talk about these both together and because they have the same formula is because if we think about like a stack of things, obviously these are not perfect. You want to imagine this is smooth. Can you see? If I imagine this stack upright, I could find the surface area of this stack. I need you to use your imagination a little bit because obviously they're not perfect. So when I lean this tower over, it's not as smooth as it is in this diagram. But when I lean this tower over, the surface area of this shape hasn't changed. Obviously, yes, it has because there's all these ridges. But if it was smooth, it wouldn't really have changed that surface area. So in this demonstration, you can see the surface area for a right prism where it's standing straight upright versus an oblique prism where we literally just take the shape and we lean it over. Just because we leaned it over isn't going to change my formula. So How do we get to our formula for the prism? Every prism has the same formula. It's really nice because once we learn it, hopefully we can use it all the time. We're going to start off with drawing a net. We're not going to have to draw a net every single time, but in this case, we're going to draw a net. This shape in particular, we know it's a prism because it has two bases. And then this one's kind of a little bit tricky because of the perspective. It kind of looks like it might be a rectangular prism. However, we're going to call this a trapezoidal prism because those bases are trapezoids. So let's label this trapezoidal. That just means that the base is a trapezoid. And I'm going to draw out this net. So I'm going to start with the base that's on the table, connecting that base to the other base is a rectangular side. And then here's the other trapezoid up there. And then we have three other lateral sides. So three other rectangles. I've got this one, and the one in the front. So that's a little guy over here, a long one, and then another little one. Okay, everybody good? Everybody got this net? Okay, now I'm going to put some labels in here. We're not going to think about values right now. We're just going to think about letters so that we can get to our formula. So I'm going to call these two bases, the area of these two bases, B. So let's label each one of those as B. When we talk about area of the base, we always use this capital B. Then I'm going to label the sides of that trapezoid. I'm going to put in some imaginary values in here. Let's call this A, B, C, and D for the lengths of the sides of that trapezoid. Stay with me here. Use your imagination. The height of this prism, aka the altitude, the distance between base 1 and base 2, we're calling that H for height. So I'm going to put those labels in here. The distance between the two bases is H for height. And then I said that the length of each one of those little rectangles, or the width of each one of those little rectangles, was A, B, C, and D. Okay, so how do we find the surface area? Well, yesterday when we were finding the surface area of nets, we were just adding all of the pieces together. So surface area, SA equals the area of that rectangle, that lateral area in the middle, is I would count up all of this bottom base right here, A plus B plus C plus D, that would be the width of my rectangle. So let's say A plus B plus C plus D, that's the width of my rectangle, times the height of that rectangle. The height of that rectangle is H. That gets me that green area in the middle. We're going to refer to that as LA for lateral area. You're going to see that abbreviation quite often. And then I have two of those trapezoids, 2 times the area of one of the bases. Area of the base we're referring to with that big B. So I have plus 2 of those areas, whatever those areas are. Obviously, we would do the whole formula, figure out the area of that trapezoid, but for right now, we're just going to leave it as B. So what are these parts that I see here? Well, big B, that's the area of the base. H is the, let's change color. H is the height of the prism. And then how did I get that A plus B plus C plus D? Imagine taking your net, folding it back up to make a 3D solid. That A plus B plus C plus D, that's going to be the perimeter of the whole base. So we're going to change this to a P in a second. Hold on. This is perimeter of the base. So if we take that formula and we simplify it down just a little bit, surface area of any prism can be found by doing perimeter of the base times the height of the whole prism plus 2 big B, which is the area of a base. Any questions on that? That formula is also right here. So it's the same thing here. And that's where I get it from. Good? Okay. Let's flip it over. Let's look at the examples. Now, in the notes packet, they kind of map it out for you. They really lay out like all the equation for you. You do not have these blanks on the notes. You do not have these blanks on the homework, and you're not going to have these blanks on the quiz or the test. These are here just to guide us through the notes for the first time. The first thing we should always do is identify our shape. So in this case, again, the perspective's a little weird, but I'll let you know. This is, again, a trapezoidal prism because my bases are trapezoids. I know that these are the two bases because I can't have non-rectangular lateral faces. So those two trapezoids are the bases. Trapezoidal prism. Okay, I'm going to do a little tiny quick sketch of this net. It's not going to be anything fancy. I just want to lay it out one more time. We're not going to have to do this every time. Okay, there's a quick sketch of my net. So the lateral area, this abbreviation, LA, represents the whole area of that green rectangle. Remember, we are going to find that by doing perimeter of the base times the height of the whole shape, the distance from one base to the other. So the height of my whole shape is this 15. It goes from one base down to the other base. And the perimeter, that P, is going to be the perimeter of one of those trapezoids. So I can see I have I don't want this color. I have the 6, the 9, the 6, and the 12. I don't even have to add them together. I'm just going to do 6 plus 9 plus 6 plus 12. Squeeze it in there. There we go. And that's my lateral area. That's the area of that rectangle that makes up the lateral faces. Then I have two bases, so I'm going to add on 2 times the area of one of those trapezoids. This is where you use your little blue sheet, or hopefully you remember them, to figure out what the area of a trapezoid formula is. I'll give you this one. This one is 1/2 height times base 1 plus base 2 for a trapezoid. So again, 2 times, I have 1/2 in my trapezoid formula. Now, this height is a little bit different. This height is different than the height of my prism that we used before. This height refers to specifically the height of my two-dimensional figure, which is my trapezoid. So this is a 6, 9, 6, 12. The height of this trapezoid, we can see it labeled there, is 4. Do we see that over here? Okay, when I'm talking area of the base, I don't care that it's 3-dimensional. I'm only caring about that 2-dimensional figure. So maybe put yourself an angry little comment over here. Oops. Angry face. The height is not 15 in this part of our problem. The height is 4. And then I have base 1 plus base 2. Those two bases are 9 and 12. So 9 plus 12 in there. Okay, do we see where this formula is coming from? All those little tiny pieces coming together to make one big formula? Okay. You can put this right in your calculator if you want to. I like to simplify down a little bit before I do put it in my calculator. So I would put into my calculator 6 plus 9 plus 6 plus 12 is 33. 12 plus 21, yeah, 33. Times the height, which is 15. Plus, now this happens a lot because a lot of our formulas have a 1/2 in them, but 2 times 1/2, they end up canceling each other out quite often. So that helps me a little bit. So I'm really just left with 4 times 9 plus 12 is 21. That makes it a little bit easier to put into my calculator. I'm going to calculate that whole thing, 33 times 15 plus 4 times 21, which gets me a nice 579. And I'm always working with units squared here. It feels like a lot of steps, but did we follow along with that pretty well? You think? Yes, maybe? Okay, hopefully. All right, let's keep going. Number 2, what would we call this shape? Any ideas? It's a prism. We know it's a prism. We look at the name of the base, which, remember, our bases are the non-rectangular pieces, unless they're all rectangles. So it's got 6 sides. This is a hexagonal prism. Okay, let's work out our formula. First things first, lateral area. I'm not going to draw the whole net this time. Lateral area is perimeter times height of the whole shape. The perimeter of my base, which my base is a hexagon, each one of those pieces is 6, and there's 6 sides. So the perimeter is 6 times 6. The height of my whole shape is the distance from one base to the other base. So that's 12. Plus, I have 2 times the area of this base. You're going to have to look at your blue sheet and figure out how do we find the area of a hexagon. Our formula is 1/2 apothem times perimeter. So I have 2 times 1/2. Now I need to find the apothem. So here's where you might want to draw out your base separately because things can get a little tight in there sometimes. I'm going to draw this base so that I can really see everything I'm looking at here. There's my hexagon. The apothem we know goes from the center down to the middle of the bottom. The whole bottom piece is 6, which makes each one of these 3 and 3. Here's the apothem. I'm going to split this into a triangle because we know how to solve these. So there's my triangle. Hopefully you remember what the values in here are, specifically because it's a hexagon and we know that's a special right triangle. But if you don't, remember that you can always do 360 divided by 6 pieces. Gets me 120. Right? Yeah? No. Sorry. 60. And then 60 divided by 2 tells me that this angle is 30, so this one must be 60. There we go. There's my hexagon. Okay, go back to your 30, 60, 90 rules. I told you they're never going away. We've got our 30-degree side, which is 3. To get to the long leg from there, the apothem, we want 3 times radical 3. Go to my formula. So 2 times 1/2 times the apothem, 3 radical 3. The perimeter of this hexagon we've already found. It is 6 times 6 or 36. Okay, so those 2 perimeters are the same. We can simplify down just a little bit. 36 times 12 plus the 2 and the 1/2 are going to cancel each other out. 3 times 36 is 108. So just simplifying stuff down a little bit before I throw that in my calculator. I'm going to end up with 619.1. And this, I believe, is in centimeters. Oh, no, meters. Okay, any questions on that? Okay, I have two more, and we have to do them because they're both a little bit different. So this third one, this is what we call a composite figure. This is when we stack two shapes on top of each other. When we think about surface area, we're talking about the area that is visible on the outside of this shape. So if I'm taking a look at this shape right here, I also think about this as like, imagine you take the shape and you dump it in a bucket of paint. What sides get painted? If I take a look at these two figures stacked on top of each other, notably, there's one side that is not going to get painted over, and it's this side that's in the middle of this shape right here. This whole side is on the inside. It's not visible from the outside, meaning it's not going to get painted if we dump it in a bucket of paint. Therefore, we can't include it in my surface area. That makes finding the area of this shape, or the surface area of this shape, just a little bit harder. We have to do a little bit extra. For composite figures, we always take these shapes apart and then find them. So I'm going to talk about the top of this shape, the roof of my house first. Let me erase this little guy right here for right now. So the roof of this house shape is a triangular prism. I know it's a triangular prism because these guys are triangles and there's two of them. I don't want to hear anybody call that a pyramid. It's not a pyramid. That's a triangular prism. So the surface area, of the top shape is the surface area of my triangular prism, but I don't want this base. Not a base. I don't want that lateral face. So I'm going to subtract the area of that rectangle. I'm going to squiggle a line under it because that's our special part here. Surface area of this prism, just like normal, is the perimeter of the base. Okay, that base is a triangle. Each leg of that triangle is 6.1, and then the base of this triangle is 7. Not 7.1, just 7. So 6.1 plus 6.1 plus 7 is a 19.2 as my perimeter. The height of this prism, remember, is the distance from base to base. So if I go from this base to this base, the height there is a 6. Everybody sees where that base is coming from. It's not always an up and down thing. It's the distance from one base to the other. Plus 2 triangular bases. The formula for a triangle is 1/2 base times height. 1/2. The base of my triangle here, the base of my triangle is 7. The height of my triangle, I'm drawing all crazy over this. The height of my triangle is this 5 centimeters. Okay, that's the surface area of that entire prism. Now I know that piece that's squished in the middle there is not going to be counted. It's a rectangle and its dimensions are 7 by 6. So I'm going to subtract a 7 by 6 rectangle from that. Does everybody see where those numbers are coming from? So I'm going to put that all into my calculator. I'm just going to do it real fast. I'm not even going to do any simplifying. 108.2 is what I got there. And now for the other part of my composite figure, I have a rectangular prism. And for this rectangular prism, let me erase all of my crazy markings here. For my rectangular prism, the part that I'm not including in my calculation is this top base. I do have the base that's on the bottom, and I do have all of the lateral sides, but I do not want to include that base on the top. So for the surface area of the shape on the bottom, I have the surface area of that whole rectangular prism, but I'm only counting one of the bases. Okay, so let's do that. So surface area, again, perimeter times height. The perimeter of that base, 6 plus 7 plus 6 plus 7 is 26. The height is the distance between the two bases. So the distance between the two bases there is a 5. Plus, now instead of 2 times b, I only want one of those b's. The area of just one base is 7 times 6. There we go. Again, I'm going to throw that into my calculator. I'm going to get, I believe, 172. And then we got to throw it all together. So the surface area in total is 108.2 plus 172, or 280.2 centimeters squared. I know, that was a lot. Did we follow the subtraction of the pieces that we don't want, or the non-inclusion of the pieces that we don't want? The overlapping? Okay. All right, one more. This one is weird. In this last one, we're given the surface area. Okay, first of all, what shape is this? I see rectangles. You could also call this a square prism because the base is a square. The side lengths are both the same, x and x. So I would take rectangular prism or square prism here. Rectangular. Okay, so the pieces of my formula once again. Lateral area is represented by perimeter times height. Those are those lateral faces. And then I have 2 bases. Those bases are squares, so it's like base times height, or side squared, whatever you want to use there. And then I'm given the surface area. The surface area is 450. So I'm going to set my entire equation equal to 450 inches squared. Then we're going to start plugging stuff in. So my bases, that's a base right there. The perimeter of that base is x plus x plus x plus x, aka 4x for the perimeter. The height of my prism is going to be the distance between the two bases, which is told to me it's 4x. I have 2 of those square bases, so 2 times base times height of that square is x times x. Everybody good with that formula? Okay, then the multiplying might get a little bit tricky, but I think we can handle it. 4x times 4x. We multiply the 4's together, we get 16. We multiply the x's together, we should get x squared. 2 times x is plus 2x squared equals 450. I have like terms, so I can combine them. That makes 18x squared equals 450. I'm going to divide both sides by 18 to get x squared equals 25. And then finally finish it off by square rooting both sides, x equals 5. So to label the rest of my dimensions, this is a 5 by 5 square down here, and the height of my prism is 4 times 5, which is 20. I know, I just did a lot of talking. Everybody okay with that? Everybody understand what's going on?